Hi, welcome to another edition of Calculus 2. Today we are going to continue our conversation about integration by parts. We were talking about self-referral cases. Let's continue that lecture. So we had the exponential times a trig last time. Now another case is some trig functions. Here an example is secant cube of x dx, whose integration by part is essentially in the category of self-referral cases. Let me just remind you some basic facts we know from trigonometry. First of all, the basic identity there is of course the Pythagorean identity, sine squared plus cosine squared equal to 1. If you take this thing and divide it by cosine squared, what do you get? You get another identity of the same category, so it's 1 plus tan square of x is equal to secant square of x. So that is a basic identity that's going to help us. We are dealing with sine and tangent, secant and tangent, and their derivatives might come in handy. So let's remind ourselves what's the deal with the derivative of either of these functions. So secant of x, what was the derivative of that? So let's see. Let's go to this picture. Rather complicated picture. So what was the secant derivative, everybody? So it was secant of x tangent of x. That's one of the forms that typically used in calculus 1. How about tangent? The derivative of tangent itself was secant square of x. So these kind of functions we hope that come in handy. So the very first few steps of this are not really related to integration by parts, rather they are related to properties of trig functions. So let's see if what we can do here. The first step is to take this and split it to two pieces like this. So these are the parts so far, but as it is, that's not going to help us. We have to replace secant by 1 plus tan squared, and then of course I can multiply and add the two integrals. So I write the first one and the second one. Now perhaps it would have been nice if I had included another one of these facts from calculus 1. What was the integral of secant of x? That was perhaps one of the non-trivial integrals there that again needs a review of these formulas. And over there you see that the integral is logarithm of secant of x plus tangent of x plus a constant. So remember, you multiply and divide by that expression, and the magic applies when you see these differentiation rules. So the first one I know how to handle. How about the second one? That is where integration by parts routine comes in. So this is secant tan squared. So essentially I'm going to take tan, separate it as u, and whatever is left is going to be my dv. So my dv is going to be secant of x tangent of x dx. Let's see if this is going to be helpful. U prime of course du secant square of x dx, that is off of this formula. dv dx is tan x secant of x. That tells me, that's the reverse of this formula, that the v is going to be secant of x. So antiderivative of this thing is going to be tan secant. So that's my uv minus v du. v du is going to be v du. Let me write them: secant of x and secant square of x dx. So simplifying, this becomes tan x tan x, let me write it, tan x secant x. In this one, mysteriously we went back to where we were at the beginning. That's what I wanted, and I'm back in that location. And it might look like for a moment that perhaps we are wasting our time, but if you look carefully, so now everything's actually working pretty nicely. So let's go ahead and rewrite what we have so far. So I had secant x, secant cube of x dx. Secant tan squared is this. And that is that formula from Cal 1. So logarithm of secant of x plus tangent of x and some constant. Or you can always bring the constant at the very end. Now I take the secant here, which is being subtracted, and take it to the other side. So here's a self-referral. You want to calculate this on the other side is the same thing. So long as the coefficients are different, we actually have it made. That when I bring it back here, I have 2 integral of secant cube of x dx. This is tan x secant of x plus logarithm of secant of x plus tangent of x, and then a constant that we had. So if I want my integral secant cube of x dx, that's going to be half of this, half of that, and half of that. Just to keep the formulas nice, you can call it some other constant, maybe c. So that's a formula for the integral of secant cube. Rather strange or unmotivated, but when you do a bit more of trig integration, this becomes one of the normal things that we are going to see. Okay, in the next chapter there are a variety of versions of this with various functions to different powers and sometimes multiplied with each other. We are going to take a look at a more extended case of secant to some arbitrary power at that point. So we have this section is almost covered up by integration by parts for self-referral cases. We did 2, and left here one problem for you to do, and here if you want to have another problem, for example, what is the deal is cosecant cube of x dx. If you're going to try your hand at it, that's a nice problem. Okay, so we are going to move to different topics, and for now we are going to stop this lecture at this point. Good luck and God bless until our next meeting.